Some decimals are repeating decimals, which means that a certain set of digits is repeated over and over and over again, going on to the right infinitely long. So for example, the decimal 0.7272727272 and so on, dot, 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 dot. The dot, dot, dot at the end indicates that the repeating pattern is to continue on to the right without end. The three dots at the end of a decimal, called the ellipsis, is one way to indicate that a decimal continues on forever with the same pattern. But this way of indicating a repeating pattern is not the best way because in some cases it may not be entirely clear what the repeating set of digits is. And the decimal number might not be quite long when might have to be quite long to when written. And it's also true that we use the dot 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 when it comes to the non-repeating decimals as well. So there's a source of confusion possible. A better way of writing and a repeating decimal is to using the overbar notation. In this notation, the horizontal bar or line is drawn above the digits that are repeating. In the overbar notation, the decimal would be written as 0.72 with a bar over the 72. And that indicates that both the 7 and the 2 are being repeated. A non-terminating decimal that has the property that a digit or group of digits repeats ad infinitum, repeats forever from some point on, is called periodic or repeating decimal. If the number of digits in the repeating group, the number of digits in the repeating group is called the length of the period. So for example, if I have 0.1 and then the 2, 3, 2, 3, 2, 3, the 2 and 3 is being repeated, so it's a repeating decimal of period 2. The 1 isn't counted. Some other examples, the 0.2151515, that has period 2. 0.666666 on forever, that has period 1. 0.142857 repeated forever, that has period 6. To convert a fraction into a repeating decimal, simplest way is to use long division. And use long division enough times until you see a repeating pattern. So when the denominator of a simplified fraction is divisible by something other than 2 or 5, then the fraction will convert to a repeating decimal. Continue long division until a repeating pattern is established, then write your answer with the bar notation. So for instance, 4/11ths, you can see we end up with, when I do the division, I get 0.3636, and it looks like that I'm just going to keep repeating 3636. So 4/11ths would be the 0.36 with the bar over the 3 and the 6. When doing the long division to find a decimal equivalent of a fraction, perhaps the division will terminate, when it comes out even, leaving a 0 remainder, and so the division has ended. And then the decimal is a terminating decimal. But what if it does not terminate? Then, it keeps on going, and there are more and more of the subtractions, but the results of those subtractions eventually must repeat since there are only so many numbers that the subtraction result can be. When a subtraction results in is a number that has occurred before, then the decimal pattern will start repeating, so we can be sure that the decimal will have a repeating pattern. Alright, so one way to deal with this, to find a repeating, so write this repeating pattern as a repeating decimal as a fraction. One trick is to make use of algebra, where I'm going to go ahead and say, let x equal to 0.22222. If I look at the repeating part, it has period 1. So I'm going to multiply by a 10, some number with 1 0 in it. So I'll multiply 10 times that. And that means you move the decimal one place to the right. So I'll have 2.22222, and on. And then I subtract. If I have 10 of these and I subtract 1, I'll have 9 of them. On the right-hand side, 2 minus 0 is 2, and then everything after the decimal is going to disappear. And then if I divide, I'll end up with x is 2/9. So this repeating decimal becomes 2/9. Try another one. let's say that I want to figure out the fraction for 0.24 repeating. So of 0.242424 and on. In this case, my period is 2. So I would multiply this number by something with 2 zeros. So let's say 100x. That would mean move the decimal 2 places to the right. So I'll have 24 and 24, 24, 24. Again, it goes on forever, so it's always going to have those dots. But now if I subtract, the left-hand side becomes 99, and the right-hand side becomes 24. So if you divide, you'll end up with 24 over 99, which if I divide by 3, that becomes 8 over 33. And if I try one more, let's say 3 and 14 repeating. Well, we can set the 3 aside if you want to write this as a, well, we want to do it in proper fractions. So let's say x is equal to 3.141414. Again, the period is 2. So I'd multiply by 100, and I'll get 314.141414. If I subtract both sides, 100 of these x's minus one of them would give you 99. 314 minus 3 is 311, and then everything after the decimal is going to disappear. So this becomes, x becomes 311 over 99.